Welcome to The Explainer. Today we're looking at a paradigm shift so massive, it's quite literally leaving the planet. The AI tools you and I use every single day are currently constrained by the physical limits of Earth. But what happens when the biggest tech companies decide to just take our digital brains and launch them straight into orbit? Well, today we're breaking down the Starmind AI-1 project, a fascinating orbital gold rush that is absolutely about to redefine the future of computing, economics, and the global space race. To really grasp why this is happening, we've got to ask a critical question. What happens when AI runs out of power here on Earth? Because right now, terrestrial data centers are hitting a massive bottleneck. We're pushing our local power grids to their absolute breaking points, and the water cooling limits required to keep these massive server farms from melting down, they're becoming completely unsustainable. Earth simply can't keep up with the physical demands of next-generation artificial intelligence. So the solution? Look up. Okay, let's dive right into this. 250. That number perfectly represents the breathtaking scale we're talking about here. Specifically, 250 kilowatts. That's the peak compute payload of just a single Starmind AI-1 unit. So we aren't talking about small communication relays anymore. We're talking about flying supercomputers with a power density that rivals top-tier facilities on the ground, floating right out there in the vacuum of space. Here's our roadmap for today. 1. The Starmind AI-1 project. 2. Designing space-grade compute. 3. The AI NeoCloud Economy. 4. The Orbital space race. And 5. SpaceX's ultimate trump card. All right, let's kick things off with Section 1, the Starmind AI-1 project. Starmind AI-1 is basically this joint venture between two absolute titans of industry, SpaceX and NVIDIA. They're building orbital AI data center satellites, and I really want you to conceptualize the physical scale here. Each satellite is 30 meters tall, featuring a massive 75-meter wingspan once fully deployed in orbit. It's an incredible contrast, right? You have this colossal aerospace structure, larger than many commercial aircraft, all designed just to support the microscopic, hyper-advanced silicon functioning inside of it. And listen, this isn't some distant pipe dream for the 2050s. Just look at this timeline. Initial prototype testing for Starmind AI-1 is scheduled to begin in early 2027. By late 2027, we'll see broader deployments of actual production orbital data centers. And this aggressive schedule is totally setting the pace globally, with China aiming to establish its own sovereign gigawatt-class space cloud by 2030. The tech is moving from concept to reality at a blistering pace. Moving right along to Section 2, Designing Space-Grade Compute. Now, what's really interesting about this is how perfectly these two tech giants complement each other. NVIDIA provides the computing core. They're supplying an optimized version of their rack-scale architecture alongside specialized Rubin GPUs and Vera CPUs designed for heavy agentic AI workloads. SpaceX, on the flip side, handles the space adaptation. They're structurally re-engineering NVIDIA's racks to be denser, lighter, and able to actually survive the intense forces of a rocket launch. Plus, SpaceX is engineering the massive thermal cooling required to handle that 250 kilowatt payload out in a vacuum. So you might be wondering, why go through all this trouble? Well, it comes down to this brilliant three-step logic. Step 1, in space, solar energy from the sun is constant and entirely free, completely bypassing the Earth's power grid. Step 2, those massive 75-meter wings aren't just for show. They act as radiative wings, rejecting the immense heat generated by the GPUs directly into the vacuum of space, which entirely bypasses our terrestrial water cooling limits. And Step 3, the processed AI queries and results are instantly routed back down to Earth using high-bandwidth optical laser links connected to the existing Starlink constellation. It's an incredibly elegant, closed-loop solution. That brings us to Section 3, the AI NeoCloud Economy. So here is the crucial point. We usually think of SpaceX as a rocket company, right? Bringing in about $4.1 billion annually from launches. And sure, Starlink connectivity is scaling massively at an $11.4 billion run rate. But AI cloud leasing, that target revenue is sitting between $40 and $100 billion. I mean, wow. It completely, utterly dwarfs their traditional aerospace revenue, essentially transforming them into a cloud computing titan. And his massive infrastructure is going to serve some heavy hitters with dual civilian and military use cases. Internally, SpaceX actually acquired xAI in an all-stock merger, meaning xAI is now fully integrated. These orbital servers will natively host and train the next generation of models, like Grok. Externally, this platform is so strategically vital that the US Pentagon is in active negotiations with SpaceX to lease data center capacity. They want to support a massive, multi-billion-dollar military initiative called the Artificial Intelligence Arsenal. And this brilliantly illustrates the sheer commercial demand we're seeing. Google has signed a massive contract to pay SpaceX $920 million every single month. That's a nearly $1 billion monthly lease, giving Google access to roughly 110,000 NVIDIA GPUs in orbit, just to power the immense compute demands of their Gemini Enterprise AI. But get this, Anthropic went even further. They signed an even larger $1.25 billion per month deal to tap into SpaceX's infrastructure for their Claude models. What's super fascinating here is that Anthropic isn't just renting space. They're actively co-developing these future gigawatt-scale space-based data centers alongside SpaceX. By utilizing all that free solar power, SpaceX plans to offer the absolute cheapest cloud computing rentals on the market, and the biggest tech companies are already buying in big time. Let's pivot to Section 4, the Orbital Space Race. As you can imagine, this is a multi-sided race. First off, you have the direct aerospace rival, Jeff Bezos' Blue Origin, planning a 51,600 satellite constellation called TerraWave, using their New Glenn rocket to deploy gigawatt-scale facilities. Then you have the sovereign competitor, China's CASC, plotting a massive 200,000 satellite constellation by 2030 to create a sovereign space cloud for military and state processing. And finally, you have the agile first movers, venture-backed Silicon Valley startups like StarCloud, Aetherflux, and Axiom Space, who are moving incredibly fast to grab that early market share. Actually, those agile startups are already making history. A Redmond-based startup called StarCloud holds a massive bragging right. They actually beat SpaceX to orbit. Yep, they deployed the very first NVIDIA H100 chip into space, and they've already successfully trained a localized large language model right there in orbit. It proves that this whole concept isn't just theory anymore, folks. It is literally already functioning right above our heads. And finally, let's move to Section 5, SpaceX's ultimate trump card, and see how this builds up to a major industry shift. Elon Musk recently noted that, quote, terrestrial data centers are a trivial problem for rocket scientists. I mean, it's the ultimate flex on traditional software engineers, for sure, but it really highlights the immense specialized engineering capabilities of SpaceX. They aren't just some software company trying to figure out hardware. They are the premier aerospace engineering firm on the planet, and now they're applying that expertise directly to data center infrastructure. But their real advantage isn't just engineering, it's pure monopoly dynamics. Because SpaceX owns Starship and the whole Falcon launch fleet, competitors who want to build their own orbital data centers often have to buy launch capacity directly from them. Think about that for a second. If you're a startup like StarCloud or Axiom trying to compete with SpaceX's data centers, you essentially have to pay a toll to SpaceX just to get your hardware off the ground. This setup gives Musk virtually total control over the launch margins of his own competitors. Which leaves us with this final, profound question to consider. If rivals must pay SpaceX just to get off the ground, who will truly control the infrastructure of the future? We are watching the creation of a brand new orbital internet and an off-world computing economy. Sure, it solves our energy and cooling crises here on Earth, but it also consolidates an immense amount of power into the hands of whoever controls the rockets. Thank you so much for joining me for this explainer. Keep looking up because the next massive leap in human computing is happening right now, right above the clouds.